rotation. So we're going to look at 1, 2, 3, 4 types of rotation, 4 different angles. Okay? The first one, we're going to rotate 90 degrees. It should be anti-clockwise, not clockwise, anti-clockwise. Is it anti-clockwise? So anti-clockwise. Right? In other words, we take a point, let's say a random point here, and we rotate it. Okay? Rotate it to somewhere here. Okay? We've got this anti-clockwise rotation. Right? If I was to take these two lines, that's going to be 90 degrees. That's what 90 degrees means. We all right with that? 90 degrees anti-clockwise. We'll do 90 degrees, then we'll do 180 degrees, and then we're going to do 90 degrees, but clockwise in the other direction. And then we'll do just theta degrees, general. Okay, so I'll just pause here for a second. Okay, so using our friend here, Mr. Arrow, okay, we're going to, as always, we're trying to figure out the matrix by using these unit vectors, 1, 0, and 0, 1. We'll start with 1, 0. If he's moving 90 degrees, rotating, not moving, rotating 90 degrees, what will it become? 0, 1. Okay? So the 1, 0 will become 0, 1. Okay? Don't even need that, right? Okay? And then the 0, 1 will become, for me doing it, see if you can figure out. Good. Negative 1, 0. So negative 1, 0. And then all we got to do, take the black, write this column first, 0, 1, minus 1, 0. And then I'm just checking to see to make sure we've got it. Rotation 90 degrees, anti-clockwise, 0, 1, minus 1, 0. Perfect. Okay? Right, if I need to multiply, if I've got a certain point, 2, 1, I can multiply, put that matrix, then 2, 1, boom, I can get the new coordinates. Okay? Right, let's do the next one. Just save us some time here. Okay, so the next one is we're going to rotate it 180 degrees. Okay? So if I've got, let's say, a vector here, point here, we're going to rotate it 180. Okay? Now, here I wrote anti-clockwise, here I wrote clockwise. 180, is that clockwise or anti-clockwise? Doesn't matter. Doesn't matter. 180 is 180, isn't it? So let's think about it again. What will happen to the 1, 0? Rotated 180 will become minus 1, 0. And the 0, 1 will become 0, minus 1. Now I write them staggered. You understand why I'm writing them staggered? So the first one I know I'm writing here, minus 1, 0, and 0, minus 1. Okay? Now I think this is an interesting one to just have a quick look at. Because let's say I want to transform a coordinate, I don't know what, I always do the same kind of thing, 1, 4. Let's have a coordinate 1, 4. So I'm going to multiply 1, 4 on it. What will I get? Minus 1 times 1, I will get minus 1, 0 times 4 is 0. And 0 minus 1, minus 1 times 4 will be minus 4. Right? So what am I actually doing? All I'm doing, I'm just flipping the sign. The 1 become minus 1, the 4 become minus 4, which kind of makes sense. Because that's 180 degrees. It's to the other side of the origin. Draw a line to the origin, and then the same amount of line continue to the other side. Okay? Cool. Pause here. Right, our next one is transforming 90 degrees clockwise. So I wrote, it's basically a negative. Okay? If this was a positive, that's usually positive angle. If you go clockwise, we call these negative angles. So we can call it minus 90 degrees. But I also wrote 270 because minus 90, I think by now you know, minus 90 in trig, that is the same as plus 270. You know that, yeah? Okay, right, so let's have a look at that. What will happen to 1, 0? 90 degrees clockwise, it will become 0, guys. 1, 0 will become, what's that? Sorry? What? 0, negative 1. Okay? 0, and the y is minus 1. And then the 0, 1, 90 degrees to clockwise will become 1, 0. So again, we write that down. 0, minus 1, 1, 0. Once you get it, it's actually pretty easy. And I'm just going to quickly check that we got the right rotation 90 degrees. Where is this? I don't have it here. Yeah, it's not written here, but yeah, it's fine. Okay, cool. We're moving to the last one. Right, so the last one is if we want to rotate theta degrees. So let's say I want to rotate it, let's say this vector, or let's take a point. So let's say I want to take a point here, and I want to rotate it by theta degrees. So this is theta. From here, I want to move to there. What matrix am I going to use? Actually, not difficult to show, but I'm not going to show here. But the matrix of transformation is cosine theta minus tan theta, sine theta, cosine theta. Quite similar to that reflection one we had, but not the same. Okay? It will be given to you in the formula sheet, so it's not a problem. Okay? Shall we do an example for that, or we'll do one quick example? Okay? So let's say this is 2, 1. I always kind of use the same number. Okay? So I want to transform 2, 1. Okay? I want to find out the new coordinates. What are the new coordinates for here? What are these? So I know that the angle, let's say they gave me the angle is 30. Yeah, I used the easy one. Okay? Okay. So we're going to write cosine 30 minus sine 30, sine 30, cosine 30. Okay? And that means we know cosine 30 is that square root 3 over 2, right? Minus half square root 3 over 2. Okay, special angles. We time it by 2. I'm not going to even finish it, guys, if you don't mind. We're just going to multiply the square. Well, I will. Always say I'm not, but I will. Okay? So that times that is square root 3 minus half. Half times 2 is 1 minus square root 3 over 2. That's the new coordinate. The new x and the new y. And that's it for rotation. So I'll pause here. No, I'm not going to pause. I will pause. We'll add a little bit motion. So Larissa is asking, is theta always clockwise? And the answer is no. We can go clockwise or anti-clockwise. Okay? The theta here is anti-clockwise. So if I'm telling you I want to rotate it 30 degrees clockwise, that's the matrix of transformation. But what if I wanted to say, actually, I want to rotate it 30 degrees anti-clockwise? I can do that. Yeah, but I still need to use this. I don't have a separate matrix for clockwise. What will be theta then? That's what you're saying. You can, or I would. Yeah, it's fine. I would just write instead of 30, I'll write minus 30. So 30 is positive. Okay, if I want to rotate it in this direction, I'll write minus 30. But it should work also with 330. We should probably check it. Okay. So I would say, okay, let's just first of all check that. Okay, so what will be the matrix of transformation if we rotate it anti-clockwise? I would write personally cosine minus 30 minus sine minus 30, sine minus 30, cosine minus 30. So if positive is anti-clockwise, clockwise will be just negative. Or, like Arne says, okay, you can just do 360 minus the 30. That's absolutely fine, because it's the same as moving 330. So you could also write cosine 330 minus sine 330 sine 330 cosine 330. All it works out the same. Okay, so we'll pause again and move on to the last little. So we finished with rotation, now we're moving to enlargement. Enlargement, just like it sounds, just zooming in, making it bigger. So I can take this triangle, which has 3 points, 1, 1, 2, 1, and 1, 2, okay? And I can rotate it, enlarge it to this bigger triangle. Okay? So what did I do here? Let's just spell it out. Point 1, 1, I moved to 2, 2. Point 2, 1, 2, 1, move to 4, 2. And lastly, can I write above? No. What is that? 1, 2 became 2, 4. What did I really do here? I doubled the x and I doubled the y. Right? So we can already think, okay, what is the matrix? You know, we can already kind of think you can figure it out, but the way we'll do it is just like we did before. So I'll put my unit vectors and get rid of them. Okay. So to try and find out this matrix of transformation, okay, I need to ask myself again. All right, I've got 1, 0. Okay, becomes something, and I'll put that one here. 0, 1 becomes something else. Okay. So the 1, 0, we basically, we can see we double everything, right? So 1, 0 will become 0. And the 0, 1 will become double the x and the y. 0, 2. Okay. So the matrix of transformation for this is going to be 2, 0, 0, 2. Okay? We multiply them, you can see, maybe we'll do 1. 2, 0, 0, 2. If we'll just take one of the coordinates, let's time it by 1, 1. Okay? We'll see if that works. So 2 times 1 plus 0 times 1 is just 2. 0 times 1 plus 2 times 1 is 2. So that means 1, 1 became 2, 2, which is as we kind of intuitively understood. Now, instead of writing this matrix, because this is matrix only one when we're doubling everything. Obviously, we need to look, I can maybe triple it. So let's say if we had a triple one. So what will I have to change? The 2 must become 3. Okay? So in other words, if the scale factor, we call that 2 or the 3, whatever, we call it scale factor. Okay? If the scale factor is k, or generally k, the matrix of transformation will be k, 0, 0, okay? I'll just pause here for a second. So, yeah, the enlargement with scale factor of k is simply k, 0, 0, k. K could be 2, k could be 3, k could even be half. Okay? Then I'm shrinking. Good. So when I say enlargement, actually it doesn't necessarily just mean large, it can be shrinking. But you're right. If I have k, which is between 0 and 1, it's actually going to be shrinking. Okay? I want us to think about one or two things. Okay, so if I have k equal, let's say, minus 2. Minus 2, 0, 0, minus 2. Okay. What do you reckon about that? What are we doing here? First of all, are we shrinking or are we enlarging? We still enlarging because, okay, that number is negative, but it's enlarging. It's going to double all the x and the y's. But what does the minus, what's that going to do? Flipping it. It's going to be, it's a matrix that we had to look. If you remember, we had that matrix. What was it? The 180, right? So this matrix is rotation 180 degrees. In other words, we're flipping it over the other side of the origin. If I have a dot here, it will go over to there. That's just that. So this thing is actually made out of two things. What is minus 2, 0, 0, minus 2? It's basically 2 times, say a scale, scalar, 2 times minus 1, 0, 0, minus 1. Right? I can multiply, remember in the beginning of the first lesson about matrices, I told you that we can multiply a matrix by a scalar. If I have a scalar like number 2 times a matrix, is basically I'm multiplying each one of the elements. Okay? So if it's negative, it's going to do two things. First of all, it's going to rotate 180 degrees and it's going to enlarge it. So it's going to take this number, flip it to the other side, and then send it double the distance. So we'll get to somewhere here. Okay? The last thing I want to just show you, I'll just pause here. So the last thing, if I just go over, let's just go over the normal, k, 0, 0, k. I can write that matrix as simply k times another matrix. What will be the matrix here? Just 1, 0. Do you remember the name of this matrix? It's the identity matrix. And what about the identity matrix? If I multiply 1, 0, 0, 1 times, let's say, any vector.
It's going to be
the same vector, right? Let's say a vector AB. Well, it's just going to be AB. So
it's the same as just saying k times 2.
Exactly. That's exactly what I wanted to say. So this matrix, it looks maybe complicated, but actually we can just take, if I want to take a certain vector AB, and I want to magnify it by k. I don't actually need to multiply by this matrix. All I got to do is times k by AB, which is KA, KA. Right? That's it. We're done.